Here we see a liquid oxygen hose being carried to the top of the fueling ladder. This hose will be connected to the missile's liquid oxygen fueling port. 2 liquid oxygen trailers, each carrying 18,000 pounds of liquid oxygen, were employed for this procedure. Here we see a liquid oxygen or LOX hose being connected to the back of a liquid oxygen tanker trailer. For Block 1 missiles, the 2 LOX hoses from the 2 tankers were connected to a Y fitting that contained a booster pump. The Y fitting used for Block 2 missiles did not contain a booster pump. The LOX tanker driver is now beginning to flow liquid oxygen out of one of the 2 LOX tankers. This was a lined pre-cooling operation. Liquid oxygen is now beginning to flow from the tanker trailers to the missile tank. The boiling point of liquid oxygen is -297 degrees Fahrenheit. Unlike the tactical missile, the trainer missile did not have a full-sized liquid oxygen tank. Instead, it employed a double-walled belt tank around the circumference of the thrust unit. However, the telltale frost band would form around the circumference of the thrust unit. When the LOX tank was full, excess LOX would flow out the LOX vent valve and down a standpipe to be vented onto the ground. At this point, the LOX trailer pumps would be turned off and the LOX trailer valves closed. LOX hoses were then disconnected and drained onto the ground. Final checkout of the onboard inertial guidance system is now taking place. The fire control and test truck contained a library of punched tapes. Each tape contained the missile's pitch program for a pre-selected target. The pitch program on a punched tape was transferred to a magnetic tape in the missile's program device. The program device was essentially a reel-to-reel magnetic tape recorder located in the instrument compartment. Once the missile was launched, the data stored on the magnetic tape would be used to sequentially pitch the missile over on a ballistic path toward the target. Range computer velocity and displacement presets would be entered at this time. The thrust unit's 4 steering rudders and 4 carbon jet vanes would be checked for proper operation at this time. The missile body's 4 air vanes remained locked in the 0 position until after missile separation. The Redstone missile's maximum range was 200 statute miles. In its ballistic path, it reached a maximum altitude of approximately 60 statute miles. The missile was rotated on the launcher to point fin 1 toward the target. Here the theodolite crew is making final adjustments to the firing azimuth. The operator is sighting in on a prism installed on the side of the instrument compartment. With fin 1 pointing toward the target, the missile was now precisely aligned along the firing azimuth. The final van checkout task was to select the air burst or ground burst option for the warhead. Warhead burst option was always carried out by a team of the battery commander and the maintenance officer. Here we see communication checks of the remote firing panel. The panel was located approximately 200 yards from the launcher. At the completion of vertical checkout, control of the missile was transferred from the fire control and test truck to the remote launcher site. The missile launch sequence was activated from the firing switch on this remote panel. A complete Redstone missile firing operation was listed as an 8-hour event. However, once established in Germany, the 40th Artillery Group firing batteries consistently performed the fire mission in 5 hours or less.